So what do we call the special shapes in group A? We know that they're all quadrilaterals, they're all trapezoids. However, group B only has one set in each shape of parallel lines. Group A has two. So what do we call these special shapes? We call them parallelograms. The definition of a parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. This means that they have certain characteristics that make them different than trapezoids and other quadrilaterals. So let's take a look at those characteristics. We know that a parallelogram is a closed shape with four straight lines. This is what makes it a quadrilateral. It has four lines and they're closed. There are no openings. And it has both sides that are opposite and parallel, meaning every opposite side are parallel lines. Now let's check this shape to make sure it's a parallelogram. If I extend this line on forever and ever until I run out of energy and room and time, my top and the bottom line are never going to meet, which makes them parallel because they do not intersect or touch. Now let's look at the side lines. If I move this up and this one, and I extend this side, once again, they are never going to touch. I have two sets of parallel lines. Additionally, we know from the definition of quadrilateral that all of my angles are going to add up to 360 degrees. However, in parallelograms, the opposite angles are equal in degree. This means that the angle right here is going to match the angle right here. And the angle over on this side is going to match the angle on this side. So let's say if angle A was, 45 degrees, that means angle C also has to be 45 degrees because they are opposite. Similarly, if angle B was 135 degrees, that means angle D has to match because they're opposite each other. I'm sorry for that pause. I had to make sure that with two angles of 45 and two angles of 135, that they both added up. All the angles together added up to 360 degrees, which they do. So think of parallelograms as matching opposites.